Hey everyone, welcome back to another lesson in MCV4U. Today we'll be looking at the intervals of increase and decrease. And here we can see that a function f of x is increasing on an interval if x is an element of these 2 points a and b, and if the function at x2 is greater than the function at x1 whenever x2 is greater than x1 in that interval. Another way to see that is that here, if we look, there's 2 points at x1 and x2. We see here that the slope here is greater than 0 or positive. So here we can write again that y prime or f prime of x is greater than 0. So here x2 is greater than x1, it means delta x, the change in x, is greater than 0, again, which means that there's a positive slope for the tangent. Here we see that a function f of x is decreasing on an interval, if x is an element of these 2 points, a and b, if the function at point x2 is less than the function at x1 whenever x2 is greater than x1 in that interval. So here we see that again at 2 points, x1 and x2, we see here that again f the function at point x2 is less than the function at point x1. Here we can see that. Also, see that the slope is going to be negative. So again, y prime or f prime of x here is going to be less than 0. So here, if we look at the slope, again, our change in y here is going to be less than 0, and our change in x will be greater than 0. So here we know that it's going to be negative over positive, which would give us a negative slope. So let's look at this first example here. So it says determine the intervals where the function f of x is increasing, decreasing, or constant. So here, if we look at our section, so we'll label the points. So label here, label this point at -4 and 2, label this point -2 and 4, label this point 0 and 2, this point 4 and 2, and then the last point at 7 and 5. Okay, so here when we start, if we look at it from -infinity to -4, there we see that as it's decreasing, or the slopes of the tangent, here we see are decreasing. Here, if we look at some of the slopes, all of these are decreasing. Now here, again, these slopes are decreasing from -4 to -2. You see that here it would be increasing, or these slopes would be positive. Here from -2 to 0. And we see here that it's going to be decreasing from -2, or sorry, from 0 to 4. We see that it neither is increasing or decreasing, rather it stays constant at a flat line here. And then finally, from 4 to 7, we see here that it is increasing. So here, if we read it again from left to right, if we read it from left to right, so here it is decreasing again when it is less than 0. So here we see that in terms of the x values. So it's decreasing. And it is, again, less than 0 in terms of the slope. And here we see that it is decreasing from -infinity to -4, and also between -2 and 0. And there we used pink as the color to indicate where it was decreasing. It is increasing here. So it's increasing when it's between -4 and -2. And also between 4 and 7. So actually, I'll change this color so it matches what we did there. So here, we'll put this in yellow as well. Oh, again, it is increasing between -4 and 2, and also between 4 and 7. And it includes 7 because it's a solid point, and so therefore we use the square bracket. There we used, again, the color yellow. And then it's constant. So it's constant, again, here between 0 and 4. So here we can write x is constant between 0 and 4, and we used green to indicate that. So to test for intervals of increase and decrease, suppose that f of x is differentiable on the interval as x is an element of the points a, b. If f prime of x is greater than 0, so if x prime of x is greater than 0, for all x values at point a, b, then f of x is increasing over that interval. If f prime of x is less than 0 for all x values at point a, b, then f of x is decreasing over that over that interval. And then if f prime of x is equal to 0, then the function is neither increasing nor decreasing at x. This means that there may be a potential local, so potential local or absolute maximum or minimum. Again, let me just repeat that. Again, if f prime of x is equal to 0, the function is neither increasing or decreasing at x. This means that there may be potential local, absolute, maximum, or minimum at x. So remember that f prime of x is the slope of the tangent. So visually, we can see these patterns on a parabola. So here we see that if it's decreasing, again, tangent will look like this, or the tangent line will look like that. If it is increasing, tangent line will look like that. And then if it's constant, tangent line will be a horizontal line. That's fine. And so here, let's look at this example. So it says determine the intervals where f of x is equal to negative 2x cubed over 3 plus x squared plus 12x minus 1 is increasing and decreasing. So in order to find increasing or decreasing intervals, we must study the behavior of the first derivative. Okay, so let's take a look at this. So here, the first thing we want to do is we want to find the derivative of this function. So here, f prime of x is equal to negative 2 over 3 times 3x to the power of 2, or 3x squared, plus 2x plus 12. Here we can simplify that. Give us negative 2x squared plus 2x plus 12. Factor the common factor of negative 2. Left with x squared minus x minus 6. And here we can factor the x squared minus x minus 6 to give us negative 2 x minus 3 x plus 2. So here we see that in terms of our derivative, we see that it is a quadratic. It's a quadratic, which is an even degree. Quadratic with an even degree. We have a negative leading coefficient. So here we see that it goes from quadrant 3 to quadrant 4. So from quadrant 3 to quadrant 4. And so now we will draw our inequality. And so here we have our two x-intercepts at negative 2 and positive 3. Here, if we sub a value in that is less than negative 2, see that the leading coefficient is negative. We sub in something that's less than negative 2. So here, if we sub in something like negative 4 minus 3 will still give us a negative value. And negative 4 plus 2 will still give us negative. So negative times negative will give us positive. Another negative will keep us negative here. So here we see that it would be decreasing from negative infinity to negative 2. So if we draw our parabola here, we can kind of take a look at that. Okay, so in between negative 2 and 3, so if we sub in, for example, 0, so in 0, 0 minus 3 will give us negative 3, so it's negative, and 0 plus 2 will give us positive. So here we see that at this point, between -2 and 3, it would be increasing. And then finally, from 3 to infinity, and our leading coefficient is negative, to sub in a value that's greater than 3, let's say 5. 5 minus 3 gives us 2, so that would give us a positive value. And then 5 plus 2 would also give us 7, which is positive as well. So here, negative times positive would give us negative. And so between 3 and infinity, it is decreasing. So again, here we'll determine the intervals. So we can write, therefore, f of x is increasing when x is between 2 and 3. And so here, this is again when f prime of x is greater than 0 or positive. And then we can see that f of x is decreasing when x is negative infinity to -2, negative infinity to -2, and from 3 to infinity. And here, this is when f of x, f prime of x, is less than 0 or negative. Okay, continuing on, here it says determine the intervals of increase and decrease for f of x is equal to x to the power of 4 minus 8x squared plus 3. So the first thing we want to do here is we want to derive this function. So f prime of x is equal to 4x cubed minus 16x. Here we can factor out 4x. We'll be left with x squared minus 4. Further simplify x squared minus 4, since it's a difference of squares, and we'll be left with 4x, x minus 2, x plus 2. And here we see that we have a positive leading coefficient, and we have an odd degree. We have an odd degree polynomial here. And so our end behavior, and here will be from quadrant 3 to quadrant 1. So here we can draw our inequalities here. So here we see that our 3 intercepts will be at -2, 0, and +2. So here, again, if we sub in values that are less than -2, we get negative value, negative, for example, sub in -4, -4 minus 2 still gives you negative value, and -4 plus 2 will still give us this negative value here. Good. So negative times negative will give us negative here, which shows that it is decreasing from negative infinity to -2. From -2 to 0, some of values such as -1, negative, -1 minus 2, still negative, and -1 plus 2 will give you positive. So negative times positive here will be positive. So there it is increasing from 0 to 2. So if we sub in 1, for example, we'll get positive. 1 minus 2 will give us negative, and 1 plus 2 will give us positive. So negative times 2 positives will give us negative value. And so then it would be decreasing. And finally, from 2 to infinity, here, so we sub in 3, positive value, positive, and positive. So it's positive here, which is increasing. Our graph looks something like this. So here, again, are intervals of increase and decrease. So here, f of x is increasing when x is between -2 and 0, and also from 2 to infinity. And again, this is when f prime of x is greater than 0. And then f of x is decreasing when x is from -infinity to -2, and from 0 to 2. And again, this is f when f prime of x is less than 0. Okay, so if we look at discontinuous functions, so consider the rational function shown here. Are the local maximums and minimums the only points where this function can change from increasing and decreasing? So not only the locals and maximums the only points where this function can change from increasing decreasing. And so because in these situations, we also have vertical asymptotes that we have to consider. And therefore, when determining intervals of increase and decrease, you must also include the points where f of x is discontinuous in your interval chart. So these are the points where the function is undefined. So let's look at this example here. So determine the intervals of increase and decrease for f of x is equal to 2 over x minus 3 squared. So here, if we derive f prime of x, so here to derive the function, f prime of x is equal, and here we'll be using quotient rule, 0 minus, and then derive the bottom, so 2 times 2 x minus 3, and then derive the top, which is just 1, over x minus 3 squared, squared again, which is to the power of 4. So here, if we simplify this, f prime of x is equal to -4 x minus 3 over x minus 3 to the power of 4. Here we can cancel out the x minus 3 from the numerator and 1 of the x minus 3 from the denominator. Here, we'll be left with f prime of x is equal to -4 over x minus 3 cubed. Here, there's no x-intercepts. What we do here have a vertical asymptote. X is equal to 3. So let's draw our inequality or interval here. And so we can draw 3 here. Goes from -infinity to +infinity. And so value that's less than 3, so we can use 0. So -4, so negative at the top. And then the denominator, if we sub in 0, 0 minus 3 to the power of 3, still be negative. So negative of negative is positive. Means that here, f of x would be increasing. And greater than 3, so we sub in value like 4, -4 over 4 minus 3 is positive. 1 cube would be positive. So here, you see that it's negative. And so here, f of x would be decreasing. Here we can write that f of x is increasing when x is between -infinity and 3. And that's when f prime of x is greater than 0. And again, f of x is decreasing when x is from 3 to infinity. Again, this is when f prime of x is less than 0. So in conclusion, again, to determine when a function is increasing or decreasing, and we must check if its derivative f prime of x is greater than 0, or if f prime of x is less than 0. Again, f of x is increasing when f prime of x is greater than 0, and f of x is decreasing when f prime of x is less than 0. And so the process that we use to analyze the behavior of a function includes, again, first taking the derivative of f prime of x, factoring f prime of x, and then creating a number line that includes the x-intercepts and or the vertical asymptotes if we're looking at a rational. And then we have to test each interval to again see if it is increasing or decreasing, and then we draw the conclusions based on that.